Question 1 asks, when an object is at rest, what can you say about its position, displacement, and distance? So for the position, I would say that it is not changing. The position is a description of where the object is located. And if the object is at rest, it's not moving, then its position is not going to change. The displacement, this will be our symbol for displacement. I'm going to say it's 0. 0. It's not moving at all. So it's wherever it starts is the same spot as where it ends. There's 0 length in between those spots. And same with the distance. The distance would also be 0. It's not moving at all. It's not traveling any distance. Number 3, a camper kayaks 16 kilometers east from a camping site, stops, and then paddles 23 kilometers west. I'm going to draw a diagram of that to start. So we can have a starting point. And the first thing the kayaker does is go 16 kilometers east, which I'll draw as an arrow to the right and label it 16 kilometers east. And then they're going to turn around and go 23 kilometers west. So they're going to go past the starting point and towards the west there. So it's a 2-leg trip. They're going to end right here. So I've drawn the starting point and the ending point. Part A, what is the camper's final position with respect to the camping site? So the camping site is where they started, actually. So the final position is where they ended. So I can do a subtraction there, 23 minus 16, basically, to get me where they ended versus where they started. And that gives me an answer of 7. Now, just based on the diagram, I know that 7 is in kilometers and it's west of where they started. So my answer is that the final position is 7 kilometers west of the campsite. B, what is the total displacement of the camper? The total displacement of the camper, so our definition of displacement is the magnitude and direction of the arrow if you draw a straight line from where they started to where they ended. So I drew that line in red. That red arrow represents the displacement. And the displacement is going to also be 7 kilometers west. It's the same answer in this case as part A, the final position. C, what is the distance covered by the camper? Is it the same as the displacement? Explain. The distance, our symbol is D, and it's defined as the length of the path traveled. That's how we defined it. So it's the entire path now. So that would equal the 16 kilometers plus the 23 kilometers. That's the length of the entire path that was traveled. They went to the east and then they turned around and went to the west. You got to add all of that together to get the entire path. That makes 39 kilometers. So that is question 3. Basically, they want you to get used to the definitions of position, displacement, and distance. They're different things. And the question asks us is the distance the same as the displacement? Well, definitely not. We calculated 39 kilometers for one of them, 7 for the other. They just have They just have different definitions. They're not the same thing. Question 5. Below, 2 children play catch using an atuk, don't know really how to say that word, a type of sealskin racket. Standing 3 meters apart, the child on the right tosses the ball to the child on the left, and then moves 5 meters right to catch the ball again. Determine the horizontal distance and displacement the ball travels from its initial position. Ignore any vertical motion. All right, so they have a nice diagram there in the textbook of people playing with these rackets. I'm going to just draw the diagram of the ball because the question's asking, what's the ball doing? So I'll have my ball. I'll just draw somewhere for it to start. Let's say the ball starts there. So the first thing that happens is that the ball gets tossed 3 meters to the left. The ball gets tossed 3 meters to the left. 3.0 meters, I should say. It does matter how many decimal places somebody chooses to tell you. It speaks to the precision of the measurement. And then the person backs up all the way to here. The person backs up all the way to there, which is 5 meters away. And once they've backed up to there, then they get the ball back. So the person's going to throw it this entire length there, and they'll get the ball back. So this is where the ball ends. I'm going to go over this with a highlighter to trace out the path of the ball. The ball goes 3 meters left, and then it gets thrown the other way, all this length here to get back to the end. So it says determine the horizontal distance and the displacement. So in terms of the distance, which is just a lowercase d, actually I should use yellow because I highlighted that in yellow. The distance is the length of the entire path. So I just add up all the pieces of that path. I have the 3 meters that it started with. And then I have to add that long piece of the path. Well, the long piece of the path is 8 meters, just with mental math. 3 plus 5 is 8.0 meters. So my distance is going to be 3 plus 8, or 11. 0.0 meters. The 0.0 matters. That's important. When we add numbers together, we are limited by the place value. Well, all these numbers go to the tenths place, so my answer should also go to the tenths place. In terms of displacement, so let's review displacement. It is the straight line from start to end, like a direct straight line from the start to the end. So I'll draw that in red. That red arrow represents the displacement. And from the diagram, you can see that that's going to be 5 meters. Now, displacement is a vector, which means you need to report both the magnitude, as I just did, but also the direction. The direction here is to the right. We do not want to say east. We want to say to the right, because that's the language that was used in the question. The question used right and left. And question 7. A person's displacement is 50 kilometers west. What is his final position if he started at 5 kilometers east? Okay, so let me just organize my information here. It's telling us that the displacement is 50.0 kilometers west. It's also telling us that the starting position is 5.0 kilometers east. And they're asking us to figure out what the final position is. So I'm going to try to draw myself a diagram. The starting position is 5 kilometers east. What does that mean? Well, there must be some kind of a reference point that they're thinking of. And they're telling us that this object is starting 5 kilometers away from that to the east. So I'll just, maybe I'll use a house as a reference point. Okay, so maybe that's some kind of a reference point, and the starting position is not at the house, it's 5 kilometers east of it. So there's the start. And this right here is 5 kilometers, 5.0 kilometers. They do use a language of northeast, south, and west, so I'll just draw myself a little compass here. Okay, now they're going to travel a displacement of 50.0 kilometers west. So from the start, they travel west 50 kilometers. This is probably not to scale, but all that way is a displacement of 50.0 kilometers west. The question is, where do they end up? Okay, where do they end up? And I'm assuming that they're asking us, where do they end up compared to the house? Compared to the house or the reference spot. So it's going to be 45.0. Okay, so when they move 50 kilometers west, well, the first 5 kilometers gets them back to the reference, gets them back to the house. And what's remaining is 45 kilometers. So that is going to be the final position. Now, position is also a vector, so we want to say what direction it is. It's west. It's on the west side of the house. Okay, so the 45 was obtained by figuring out what this missing length is here, which is done by a subtraction. 50.0 minus 5.0 is 45.0.